Become the pupil with maths expert Wendy Fortescue-Hubbard and see a simple way of teaching pi.
Circles, circles, circles. I've got them everywhere in my kitchen. We can use those circles to introduce the relationship between the circumference and the diameter of a circle. It should be fun, it should be exciting, and it should be practical. When we're looking at the circle, the first thing we need to do is we need to know about the parts of the circle. And I've brought my cake tin along to do that. The first thing we need to know is what the widest part of a circle is called. And I can do this by adjusting my ribbon till it goes to the widest part. Now that there, where my blue ribbon is the widest part of the circle. That is called the diameter. Next, we need to have a look at the outside of the circle. So when we have our compass and we draw a circle, it is the piece we draw with our pencil. That is the perimeter of the circle that we call the circumference. And I can show you this with my ribbon going around the outside. Now I need to take you to the really magic bit. Here are some tins. You can go into any kitchen cupboard and you can find tins. Children can show their parents how this works. I know that my students have done so in the past. Okay, here we've got the circular end. The widest part is the diameter going across here. Now, if I take this label off very, very carefully, let me see, we'll just cut it off with my scissors. Okay, and we peel this label off the tin. Watch what happens. I think it's really quite clever. Right, if I take this label and I fold it in about 3, can you see there's 3 pieces there? I can place that across the widest part of my circle, the diameter, and it fits. Magic. I've brought with me my cake tin. Now, when I'm baking a cake, I need to line my tin. I have to put a circle piece in the bottom and I need to put a piece around the circumference. Well, we can take out the circular bottom, there it is, and we're left with the circumference. Right, now what I need to do is take my paper, draw around my circle, and cut it out. So now I've cut out the circle for the bottom, I can use that to find my diameter. If I fold this circle in half, then I have the widest part of the circle. So here's my diameter. And if you remember from the tins, if we do that 3 times, then we get the circumference. So we can take our paper. Here we go. We'll start at this end. 1, 2, 3. And I need to add a little bit because actually this number isn't exactly 3. It's a very special number that we call pi. And it's a number that's 3.142 and it goes on forever. I can take this piece of paper and we can see that it will fit into my tin with just a tiny bit left over. Well, we've been working with tins and we've been working with cake tins. And we could work with lots of other circular objects and we'd get the same result. 3 and a bit seem to figure quite a lot. 3 and a bit. But 3 and a bit is actually a very special number. It's a number that we call pi. And we have a symbol for it, like 2 legs with a lid. its actual value, we don't have an exact value, but we do know that it starts as 3.142, number, going on forever. Let's return to where we were before. We had the circumference, and we had the diameter. I don't like writing words, it takes too long. I'm a mathematician. I like to use letters. So instead of writing circumference every time, what I'm going to do is I'm just going to write C. And instead of writing diameter every time, I'm just going to write D. Think back to that cake tin. I took the diameter and I said multiply it by about 3. And I said the number we actually wanted was pi, about 3. And that gave me the length of the circumference around my tin. So if I multiply the diameter by pi, I end up with my circumference. What about the tin? When we took the tin, we had the circumference, and I divided the circumference by about 3, but I said it was actually a number that was slightly bigger than 3. And this gave me my diameter. Now we've got two ways that we can calculate either the diameter or the circumference. If I know the diameter, I can multiply it by pi, this number which is about 3, to get the circumference. If I have the circumference, I can divide it by pi to find the length of the diameter. There are lots of other practical applications for using these formulae. Students will know one very well, and that is when you come on your bicycle to school, your mileometer uses this formula to work out how far you've gone. That's pi in my kitchen.